Hello friends, now we solve the given differential equation y double dash minus 13y dash plus 12y is equal to x. How can we solve this type of differential equation? So you know that this differential equation my y double dash minus 13y dash plus 12y is equal to x. This can be also written as d2y by dx2 minus 13 dy upon dx plus 12y is equal to x. You know that this is the second order linear differential equation with constant coefficient, because here the differential coefficient present, this is second order. Here the highest order differential coefficient is d2y by dx2. So this the order of this differential equation is 2 and the power of this differential coefficient is 1. So this is the first degree and second order linear differential equation with constant coefficient. You can see here, this is the coefficient of dy by dx, this is minus 13 which is constant, coefficient of y is also constant. So this is second order linear differential equation, second order linear differential equation with constant coefficient. You know that this is the second order linear differential equation with constant coefficient. So for solving this can be written as, here we know that capital D, this is equal to d by dx, and capital D square, this is equal to d2 by dx2. So this can be written as d2y and this can be written as dy plus 12y is equal to x. Now we taking common y, so we get here d2 minus 13d plus 12y is equal to x. Now we find the auxiliary equation, and for auxiliary equation we replace this capital D by small m. So we get the auxiliary equation m square minus 13m plus 12 is equal to 0. This is the quadratic equation in m. So we find the factor of this quadratic equation. So this can be written as m square minus 12m minus m plus 12 equal to 0. Now taking common m here, so we get m minus 12, and taking common 1 here, we get m minus 12. So m minus 12 is common here, we get m minus 1. So the factor of this quadratic equation, auxiliary equation, is 1 and 12. These are the factor of the auxiliary equation. You know that these roots are distinct, and we know that if the roots of the auxiliary equation are distinct, so the complementary function can be written as c1 e to the power m1x plus c2 e to the power m2x. We put here values of m1 and m2, and you can see here m1 is 1 and m2 is 12 here. So we write the complementary function is c1 e to the power x plus c2 e to the power 12x. So this is the complementary function. Now we find the particular integral of the right hand side x. So particular integral can be written as 1 upon fd times and this x, that means q. So you know that this can be written as fd times y is equal to x. So fd is here 1 upon d square minus 13d plus 12 times x. Now we using here binomial theorem. So this can be written as fd can be written as, taking common here 12. So this can be written as 1 plus d square minus 13d upon 12 whole power minus 1. This can be also written as, when we take common 12 here, in the denominator. So this d square minus 13d divided by 12. So this will be 1 plus d square minus 13d upon 12, and when we take in the numerator, the power will be negative. Now we use expansion of 1 plus x whole power n here. We know that expansion of 1 plus x whole power n is expansion of 1 plus x whole power n, you know that 1 plus nx plus n minus 1 upon factor 2 x square and so on. So we use here the expansion this 1 plus x whole power n. So suppose that this is equal to x, this is x here and this is n here. Using this expansion, so we get 1 upon 12 times 1 plus nx. N is here minus 1 and x is here d square minus 13d upon 12 plus here this n minus 1. In place of n there is minus 1, so minus 1 minus 2 upon factor 2 and x square. So we take here the term second term only, because here the power of x is 1. So we take only those terms in which power of d is only 1. So we don't take this term and we write here x. You can see here the power of x is 1. So we take only those terms where the powers of capital D is 1. Here the power of x is 1, so we take only those terms in the expansion of 1 plus d square minus 13d upon 12 whole power minus 1. We take those terms only in which power of d is 1. So this can be written as 1 upon 12, 1, and this plus minus 1 by 12 here, and we write here d square minus 13d. Now we multiply this x inside the bracket and get here, we multiply x inside the bracket, we get here 1 by 12 times x multiplied by 1, we get x, and 1 by 12 times d square x minus 13 dx. You know that d square x, that means this here we differentiate x 2 times, we get 0, and 13 here we differentiate x 1 time, we get 1. So this will be 1 upon 12 times x minus and this minus plus here, and this is 13 upon 12. So we taking LCM here, so we get 1 upon 144 times 12x plus 13. So this is the particular integral of the given differential equation. Now we write the general solution of the given differential equation. Now for the general solution, you know that we write here y is equal to complementary function plus particular integral. This is the general solution of the given differential equation. We write here general solution. So complementary function is here c1 e to the power x plus c2 e to the power 12x, and particular integral is 1 upon 144 times 12x plus 13. This can be also written as y equal to c1 times e to the power x plus c2 times e to the power 12x plus 12, 24, 144. So x by 12 here, and this is 13 upon 144. So this is the solution of the given second order linear differential equation with constant coefficient. Thank you.